Hello class and welcome back to Holbert Helps. I'm your teacher, Mr. Holbert, and today we're going to be going over solving for one variable equations, but we're going to be going over solving for one variable equations that are a bit spicier, things that I would expect Algebra 1 students to be able to solve. If you are shaky about being able to solve for one variable equations, or you don't even know what I'm talking about, I have a earlier video that I'll link in the description or after the video that you can click on and you can go watch that. That goes over some examples and how to actually solve for one variable equations. But if you are watching this video, I'm assuming that you know how to solve a basic one variable equation. You came here for just some extra help and maybe some tips. Okay, to start this video, we need to start off talking about our order of operations. Bit of a weird way to start it, but we need to talk about PEMDAS. Parentheses, exponents, multiplication, division, addition, and subtraction. These are our order of operations, and we use it whenever we are evaluating an equation. So for example, if I had something like 3 times 5 minus 2 plus 10, and I set that equal to, well, like what does that equal? We need to evaluate it, okay? So if I follow our order of operations from top to bottom, first things first is we need to check for parentheses. Nope. Exponents, there aren't any. Multiplication. Multiplication and division, by the way, are interchangeable. They both happen at the same time. Okay, so I do have multiplication here. So we do 3 times 5, which is 15, and we're going to write the rest of that equation below. So now we have 15 minus 2 plus 10. Okay, now we go through this list again, and all that we have left over here is addition and subtraction. And just like multiplication and division, these two are also interchangeable in terms of the order. So I'm going to subtract these two and get 13 plus 10. And then 13 plus 10 is 23. Okay, so that is our answer. What makes our order of operations so important is that we have to follow it. We had to have some type of standard, excuse me. The reason why is, well, what if instead of multiplying, I decided I want to subtract this first to get 3. 5 minus 2 is 3, so then our new equation would have been 3 times 3 plus 10, which then this becomes 9 plus 10, and that equals 19. 19 is very different from 23. So we needed some type of standard for us all to solve, or excuse me, evaluate our equations by. PEMDAS is something that you should always keep in mind and that you should respect. However, when it comes to solving for one variable equations, what you actually want to use is SADMEP, or SADMEP, I'm not sure. But it's just PEMDAS, but backwards. So instead of parentheses being on top, it's actually on the bottom. We want to do subtraction and addition first, then look for division, multiplication, and last but not least, check our exponents or parentheses. The reason why we want to do this is because, well, it would just be easier to show you. But before I show you, I just want to make the record clear that no, your math teacher didn't lie to you about PEMDAS, or no, it's not useless or anything like that. We still need to respect PEMDAS. However, we use that for evaluating equations. Here, for a one variable equation, which if you look here, I have one variable and it happens to be x. When solving for it, I'm not evaluating the equation, I'm solving for a variable so that when I do evaluate it, it makes it true, the original equation true. So we should follow this instead. And let me give an example. Let's say that I'm going to solve this using PEMDAS instead of our SADMEP. And if I was to do that, I need to go bottom to top because we flipped it. And we check here, no parentheses, no exponents. Oh, I do have some multiplication though. Right here, I have 3 times x, 3x right here. So I would like to move that over. To do that, I need to divide everything by 3. So divide this by 3, divide this by 3, divide this by 3. These cancel out, and now I am left with x plus 4/3 is equal to 16/3. For the record, this is perfectly okay. We could continue to solve this equation for x. However, a lot of you just kind of started freaking out a little bit. We went from a fairly simple equation to something that looks extremely complex. We got two different fractions. Our variable over here isn't even by itself yet. We're making the problem harder than it needs to be. We can still solve it. There's nothing wrong with what we did here. However, there is an easier way to go about it, and that is using SADMEP. So instead of dividing by 3, let's try something different first. And that different thing that we're going to try first is checking for subtraction or addition. Can I subtract or add anything over? And if I look here, there is. I want to isolate the x all by itself, so I need to get rid of all of its friends. And this positive 4 is a friend that we can move over. So let's move it over to the other side of the equation. Subtract 4 from both sides. These cancel out. I get 3x is equal to 16 minus 4 is 12. Now, this looks a lot more reasonable, doesn't it? Our variable is almost by itself, and we have all of our constants on the other side. So if we look over here, let's check again. Subtraction or addition? No, we're good there. Division or multiplication? Yep, we certainly have multiplication right here. 3 times x. So let's go ahead and get rid of that 3. Divide both sides by 3. Over here, these cancel out, and I'm left with x is equal to 12 divided by 3 is 4. And there's our answer. Okay. Notice that this time around, we were able to avoid any fractions in it except for at the end, but this was just simple division. And we were able to keep the problem pretty neat. So when solving for x, you should follow SADMEP instead. Do the easy things first and then try to get some of the other stuff out of the way. So for the rest of this video, I'm going to be going over examples, and as I go over these problems, I suggest that you pause the video and that you try to solve them yourself first, then continue watching them. Okay, let's move on to that next problem. All right, now we're on to our next problem. If you look here, it's a little bit spicier. Instead of x, right here we have a w instead as our variable, which as a reminder, just because I changed the letter does not necessarily mean we solve it any differently. So we're still going to treat this as a one variable equation and try and isolate our variable to see what number it needs to be. Now, I don't mean to break your guys' hearts right after I taught you this SADMEP thing, but one thing that you do need to keep in mind is that the principles of PEMDAS still hold. And what I mean by that is, if we look here, we have some parentheses, right? However, I want to look for subtraction and addition first. And I do have that here. I have a -2. I cannot just add this 2 to the other side. Unfortunately, that is not okay, not allowed. And I know that you might just be trying to follow SADMEP. You were like, hey, Mr. Holbert, I'm just trying to follow what you just taught me. But our other principles of math still hold true. I cannot alter the inside of these parentheses until I drop them, either by solving the inside, by doing the distributive property, however I want to do it. So I'm going to rewrite this equation right underneath. And while I would like to do SADMEP, let's instead find a way to drop these parentheses first. And I would suggest doing it by distributing this 3 into the parentheses. So 3 times w, we get 3w. 3 times -2 gives us -6, and that's equal to 15. Now, I don't have anything inside parentheses, so I'm good to start following our SADMEP. Okay, first off, do I have any subtraction or addition? And I certainly do. I have this 6 right here. So let's add the 6 over. Add the 6 over. Now on this side, these cancel out, and I'm left with 3w is equal to 15 plus 6 is 21. And now w only has one friend left, so let's divide both sides by 3. These 3's cancel out, and I'm left with w is equal to 21 divided by 3 is 7. W is equal to 7 is the final answer for this problem. Another way that you could have done it, besides distributing the 3 through, is you also could have divided both sides by 3 at the start. What that would have done is that these 3's would have canceled out, and that would have let us drop the parentheses. So there's 2 different ways you could have gone about this. Once again, this was kind of an example of when you need to be careful about using SADMEP. I still suggest using it. It's still the way that you should go about these, but watch out for your parentheses. They can be tricky because you can't always go in there inside of it and start messing with things. Usually you need to drop them first, whether that's by distributing or doing something else, and then you can start following your SADMEP. Okay, let's look at another problem that's a little bit spicier. All right, now we're on to our next problem that we have here. Our variable this time is u, and if we look, we have it on both sides of the equation. As a reminder, class, just because I have 2 separate u's on opposite sides of the equation does not mean it is no longer a one variable equation. We still only have one type of variable, so it is still only a one variable equation that we can solve for. Okay, let's follow our SADMEP and let's isolate our variable on this side of the equation. Let's get it all alone on this side. So I'm going to check here and see if there is any subtraction or addition. And there is. We have this 14 right here. So let's subtract 14 from both sides to move it over. Those cancel out. And over here, I'm left with 3u is equal to 3 times u minus 7 minus 14. Okay, now let's pause here. And instead of checking SADMEP again on this side, let's move on to this side. Because we already checked for addition and subtraction on this side, let's see if there's any over here that we need to do. And if we look here, we have this 14, but we just moved it over, so we don't want to move that back. But we do have these parentheses right here, which, as we can recall from last problem, these are a bit obnoxious. We need to drop them somehow. We need to remove them. And how we're going to do that is distributing through. So let's distribute our 3 inside. So this side remains the same. I still just have 3u is equal to 3 times u, which is 3u. 3 times negative 7 is, excuse me, negative 21 minus 14. And since I distributed that 3 through, I can drop our parentheses. Okay? Now, once again, let's check SADMEP on this side. Well, I do have a 3u here, and I don't want that on this side. I want it on the other side. So let's subtract our 3u over. And we'll bring the 3 with, because why not? Okay, those cancel out, and over here I have 3u minus 3u, which happens to be 0. Bit strange, okay? And then over here, I still have negative 21 minus 14. But we can combine like terms over here and get 0 is equal to negative 35. And that is our final answer. Now I'm sure there might be some alarm bells going off in your heads looking at this answer. It's a bit strange, right? 0 is equal to negative 35. How can that possibly be true? And the answer is it's not true. That is not possible, right? How can 0 possibly equal negative 35? So our answer for this one is no solution. It is possible for there to not be an answer. And when that is the case, it's no solution, and we can tell when we get to the end and we're left with no variables and we have 2 things on opposite sides of the equal sign that don't make sense. For example, 0 is equal to negative 35. How could 0 ever equal that? That is a blatantly untrue statement, so we don't have a solution. Keep an eye out for these no solution problems. They are possible. I don't suggest trying to eyeball them to try and figure them out. Instead, I suggest you just solve all the way through, get to the end, check if the answer makes sense. If there's no variables and the answer does not make sense, it's no solution. And for the record, for my students out there, most teachers require this right here. Because if you leave it here, well, unless you put the slash, but if you leave it here, that's just an untrue statement. You need to follow it up with no solution so that they understand that you know, okay? All right, a couple more problems left. Let's keep practicing. On to the next one. Okay, class, here's our next problem. We have 5q divided by 2 is equal to 25q divided by 10. Fractions, am I right? I love fractions, but I know that a lot of you are a little bit shaky with them. With this one, I want to remind you guys about an excellent strategy to use when solving for one variables or solving for equations in general. And that is, if I have two fractions across from an equal sign from one another, I can do something called cross multiplication, where I multiply this top by this bottom and this bottom by this top. So I'll get 5q times 10, which is 50q. And then over here I'll get 2 times 25q, which also happens to be 50q. Keep cross multiplication in mind. It is an excellent tool. Anytime you have fractions across an equal sign, feel free to use it. One thing that I do want to remind you about, you do not cross multiply when you are multiplying fractions together. You do it for solving equations, okay? Just quick reminder, I have students try to do that a lot. Okay, 50q is equal to 50q. So look over here, go through my SADMEP. Let's see, there's no subtraction or addition, unfortunately. There is multiplication though, this 50. So let's divide both sides by 50. Divide this side by 50. I get, let's see, q is equal to q. All right, that seems reasonable, right? Now, I still have something over here though, so let's divide our q over. Now, when I divide two things when I divide something by itself, it actually doesn't disappear, it turns into 1. So this equation right here turns into 1 is equal to 1. And that is our final answer. And welcome, class, to our last possible solution we can get from these. This is all solutions. So when you're solving for a one variable equation, you got three possibilities. First off, you have one answer. You solve through it and you get something nice and pretty like x is equal to 4. Wonderful. We have no solution, which we saw in the last problem, where we get to the bottom and we have two things equal to each other that aren't actually equal to one another without a variable. And our last answer, which is all solutions, where we have something equal to the same thing. Here, 1 is equal to 1, which is true. So all solutions would actually work for this equation. Once again, for my students out there, make sure that you write all solutions, because while this is all excellent work and getting to here isn't wrong in any way, we want to know that you understand what it means to have 1 is equal to 1. What does that mean? Make sure you write all solutions. Okay, we're going to go over one last example, make this one a little bit spicier above even this one, which had fractions in it, which I know is the worst thing in the world. So with that being said, clear off the board and we're going to move on to our last problem. All right, class, welcome. We have arrived to our last problem of the lesson today. We have 4t minus t is equal to 16 times 4 minus 2t. Man, that's a lot of t's, right? And there's just a lot of problems there. So let's get to work though. First off, let's start checking our SADMEP. Subtraction or addition. On this side, is there anything I can subtract or add over? Not really, because I'm going to put my variable on this side. However, I do have like terms that I can combine. So let's go ahead and combine those. 3t, because 4t minus t is 3t, is equal to 16, 4 minus 2t. Okay, now, once again, let's check SADMEP. Anything here that I can add or subtract over? Nope, okay. Let's take that and let's apply it to the other side. Anything I can subtract or add over? Once again, I can't really just start pulling things out of these parentheses. I still have to respect the parentheses. So we need to drop them somehow. And once again, I suggest we drop them by distributing the 16 in. So I get 16 times 4, which is 64. And then I get 16 times negative 2, which is negative 32. And then the t is still there. And now I can drop my parentheses. Okay. Parentheses are dropped. We distributed the 16. Once again, let's check here. SADMEP. Is there anything that I can add or subtract over to the other side? And as a reminder, I want my variable on this side. So I'm going to check the 4 variables over here. Sure enough, I have a 32t that I can add over. So let's add that over. 32t. 3t plus 32t is 35t, which is equal to 64. Okay, excellent. Now, let's continue. Our variable is still not alone. It still has a friend, that 35. So let's get rid of that. Divide the 35 over, divide the 35 over, and I get t is equal to 64 divided by 35. And that is our final answer. You can simplify that fraction a little bit if you would like to. Let's see, shall we check the handy dandy calculator while we're at it? Let's see, 64 divided by 35 does not simplify. What a wonderful world we live in. So, we're done here. That is our answer. T is equal to 64 divided by 35. For the record, I have so many students who do all this work and it looks fantastic. And they get here, they get a fraction, they pause, and they're like, I messed up somewhere. Class, that is not true. You can get fractions for your answers. Have some confidence, okay? We got here, all this work was great. This is our final answer. If you end up getting a fraction at the end of your problems and you're not sure about it, take it and plug it back into your original equation and see if it makes it true. It's a lot of work, but it's a way to guarantee that you didn't make any mistakes along the way. We tend not to do fractions too much up until for answers at least, until you make it to high school. The reason why is that we're trying to build your confidence. But fractions are still a valid answer, okay? Don't think that you failed just because you get here and you get a fraction out of it. All right, class. With that being said, that was our lesson for today on solving for one variable equations. Keep this idea of SADMEP in mind, get some more practice out there, and I hope to see you for another lesson. Thank you.